You know, it's a funny thing, but in a lot of ways I think we've been duped. I think we all signed up for a goal that was the wrong goal. And the goal we signed up for was a database management system should be powerful yet easy to use. Powerful yet easy to use was the wrong goal. We should have asked for business relevant yet easy to use. Helpful in making decisions yet easy to use. Important to the person who's paying for the system and easy to use. Those are the kinds of things we should have been asking for. It's so easy to fall in love with your own technology. Those of us in the computer business love computer technology. In the database business, we love database technology, and we think everybody ought to love it. Probably happens in the media business. I hear we're going to have 500 channels of TV. I'm not sure I want the channels of TV that I have, let alone 500. And so if we look to the technologists to tell us what we should be doing, we're probably not going to get what people really want. I started out, I was a computer programmer. And I had one of those jobs that was kind of like I worked in a closet. They'd slide the specification in under the door, and I'd work all day long, and 6 months later, I'd slide a program out underneath the door. Actually, in those days, it was on punch cards, if you can believe that. And, I probably said 4 words to a human being all day long, and I thought that was just a great job. Years ago, and right after we'd shipped Arbase 5000, I was down in customer support because we'd all go down and spend a couple hours on the lines trying to learn what people were doing with our product. And this fellow called up. He said, I want to keep track of my sales orders. So I bought your product, and I brought it home, and it looks fine. I opened it up and looked in the documentation, in the index, under S for sales order. And, of course, he didn't find sales order. What he found instead was select and sort by. And he said, I know this isn't a rare problem. After all, there's 4 million small businesses in the U.S. today, so I figured maybe you called it something else. So I thought, well, maybe it's invoice. So I looked in the index under I, and I found index and inverted list. And so I want to know, what should I do? Because I want to keep track of my sales orders, and I've bought your product. And I was haunted by that conversation. I mean, it just seemed like we failed this particular customer because his needs were up here at this level, and our technology was down here, and there was a huge gap. So I woke up one morning, and I'm asking myself, how can I be an information systems specialist if I don't know what information is? What's information made of? How do you know when you have more of it? What is it? If I take information, write it on a piece of paper, put it in front of my dog, is there information there? Probably not. But if I put the same piece of paper in front of somebody who knows something about that business, there's probably information there. What is that? Where is the information? Is it on the paper or is it in somebody's head? If we were going to be successful at building a system that would enable people to describe their world, we needed to know how they describe their world. And it turns out that there's 250 years of thinking about epistemology. How do people know things? How do they store knowledge? I went back and I read people like Immanuel Kant, and one of the things that he said and the other transcendental philosophers said was that reality is forever unknowable. Realizing that truth was incredibly liberating, because what it meant was, in point of fact, I had no idea how to model reality. And I was happy to read from Immanuel Kant himself that it was an impossible task. But what I got from that was that people make models of reality, and therefore, if we could model how people model reality, we could build systems that people would find easy to use. Well, the term semantic means meaning. And what it refers to is that we're storing data about data. We're storing the fact that area code and local number are combined together in another name, phone. And when we record that fact, we're not recording a particular phone number, we're recording a fact about phone numbers. A semantic object is something that people care about, something that they want to track. It's a customer, or a sale, or a shipment, or an item, or a region, or a salesperson. It's something that's in the user's world that they want to keep track of. And semantic objects have characteristics that people want to assign to them. So that customer has a name and a phone number and a fax phone number and an address and so forth. A semantic object model is simply a collection of semantic objects that represents some business or department or some individual's world, the world that they want to keep track of. We had a yacht broker who happened to be across the street from where our offices were, and we brought him in one day just to see if we could model his business. So he comes in and sat down with me, and maybe 20 minutes or so working with him, and I'm asking him about his business, and I'm building this model. It turns out a real complicated business. And about half an hour into it, I had to get up and leave to an unexpected meeting. So I said, "Gee, Tom, we'll have to pick it up again tomorrow." And he said, "Well, would you mind if I just sat here and finished the model?" Now, this is a man who'd never done data modeling in his entire life, and but he knew his business. For which, one of the things I learned from that is we in the computer business often say end users don't want complexity. That's not true. In fact, it's kind of arrogant, because you walk down on any production floor, you're going to find plenty of complexity. So I think in truth, the right statement is that end users don't mind complexity as long as it's their complexity. But what they don't want is my complexity. People, in the way that we think about things, it's a very natural thing for us to chunk things together, to combine them together. Now, what we have to do is we have to build products that support that, where it's a natural characteristic, a feature or function of the product to be able to say, area code, local number belong together, let's put them under a common name, phone, let's collapse them when we need to, let's open them up when we need to. We've had users come in, and it's amazing to me. Sometimes they'll chunk things 4 or 5 levels deep. I mean, these are not people who have been taught anything about cognitive science, they don't know anything about data modeling, but it's the way they think about their business. I used to think that if I could just ask the users the right set of clever questions, that they would tell me exactly what they want, and that I'd go build that and we'd be done with it. But what I've come to realize is that it doesn't really work that way. And in fact, there's a wonderful sketch by Escher of 2 hands drawing each other. And I think that sketch symbolizes really well what the relationship is between information systems and organizations. It's not strong enough to say they influence each other, they create each other. What I mean is that when I build an information system, hopefully I give the people in that organization a new set of behaviors. And as they behave in new ways, they're going to have new information requirements, which then they'll feed back to the information system, will change the information system, thereby give them a new set of behaviors, and so forth. A lot of times when I talk about this technology with people, there's a lot of people who are real open to it, but there's another group of people who aren't very open. And sometimes I think it's like presenting a player piano to a room full of concert pianists. I mean, there are people out there who are really good at building applications, and they look at this technology and they think, well, I really can't do what I'm doing. There is a lot of art in elegant code. The problem is that art is also very, very expensive. And, if we could all afford to hire a truly gifted programmer to write all of our database applications, well, that'd be a great thing to do. But we can't afford to do that. We can't afford the time that it takes. We can't afford the delays whenever the business changes and we need to hire that person. In fact, I think what this technology really enables the really gifted programmer a place to work. Build the tool that constructs applications for other people. Focus the elegant programming on the products that other people use to build their applications. I'd like to create the technology so people could help themselves. I'd like to bring products to market such that people wouldn't need a database disaster repair person. So much of what we've done is to take the knowledge and experience I've gained over the years and put it in a box, put it in a product. I think we'll know that we've succeeded when we find people who are not database technologists able to create applications for themselves and better run their business. when people are using applications that they created or that they caused to be created, that help them make better decisions, that help them be more productive in their work, that help their work group somehow accomplish its function better. When people are doing that without having to spend months in agony and tremendous expense, when people can do that, then we've succeeded.